So as said before, we are going to talk about the usage of large language models for intelligence analysis, and particularly we will see how we can build the knowledge graph starting from unstructured text data and using these models, and in particular GPT. But let's start from the beginning, that is represented by large language models. These models, also known as LLMs, are deep learning models that have emerged as cutting-edge systems because of their ability to understand, process, and also generate natural language. These are general purpose models in the sense that we can use the same model for performing different tasks or working on different domains. For instance, we can use a single model and process different type of data. For instance, data coming from police reports or incident reports, but also financial transaction records and historical data, documents talking about biology, or documents talking about state a corruption case, as we will see later. And we can also consider a single model and perform with this unique model a variety of different tasks. And among the most important ones related to the intelligence domain, there are question answering in case we wanted to process a huge amount of documents and answer some question based on their content. But we can also perform, by using these models, text classification. If we want to classify a document based on its content or a web report as reliable or not. We can also do document summarization and information extraction. Information extraction is the task that allows you to automatically extract information from unstructured documents and to represent them in a structured way. And this is the task that we will see, because this is the task that allows us to build a knowledge graph starting from unstructured data. So the fact that with these models, we can now perform this task easy or in an easier way, it's unlocking new opportunities. But let's see information extraction, the information extraction task, or better, information extraction pipeline. Because this is essentially a field that has some smaller tasks, and the main task that we have in this field are name identity recognition and relation extraction. The first one, name identity recognition, but also known as NER, identifies name identity mentions in a structured text, and it classifies them into some predefined categories. And among the most important categories, there are, for instance, person, organization, money, location. So here in the example, there is a sentence, and are highlighted some entities that would be the result of the name identity recognition. So we have Smith, that is an entity of type person, and 45,000 rents, that would be another entity of type money, detected by name identity recognition tools. Now, relation extraction is instead the task related that allows to identify semantic relations between entities mentioned in a structured text, and again classify them into some predefined categories based on their meaning. So by reading this sentence, we can understand that there exists a relationship between Smith and 45,000 rents, and this relationship can be expressed by using receives amount. Now, what we wanted to perform is analyze unstructured text and represent them by using a knowledge graph. In this case, in this presentation and later in the demo, we will see this process applied to some judicial reports about the state capture that happened a few years ago in South Africa. And essentially, we will use large language models for performing the two tasks that we saw before, name identity recognition and relation extraction, in order to extract the information, the relevant information that is contained in this text, and represent them by using a knowledge graph that is a unified, in our case, will be the unified source of truth of the state capture story. But let's come back to the large language models, because these models represent game changer in the natural language processing domain. Indeed, before, previously with the traditional NLP models, for performing named entity recognition or relation extraction on our on a specific use case, we needed to train our own model on the selected domain. And this requires some months of human annotation in order to create a good data set that was representative of the documents themselves, so that we were able to train a model on this selected dataset, and then where necessary some data science and engineering skills in order to train the model, train, fine-tune, but also deploy the model. So this was a very time-consuming task, and it requires also domain experts. And in the end, in some cases, it happened that despite the time spent, the results were not good enough. Now, with the large language models, we can completely skip the first two steps. Take the model and apply this model for performing our task, named entity recognition and relation extraction. And we can do this because the large language models are pre-trained models, in the sense that these are trained on a huge amount of text data, so that these models achieve a good understanding of the natural language, so that we do not need to teach to them how to accomplish a task, but we can just ask them to do that task, and they will perform the task. But as I said before, since these documents, these models are general purpose, we can consider the same model and apply it to different domains for performing different tasks. For instance, question answering, text classification, and many others. So in this sense, we can say that large language models are bringing a paradigm shift, because while before there were a model-centric approach, and for performing 100 different tasks, we needed 100 different models, each of them trained in a supervised manner, we can now perform 100 tasks by using a single model. And this, of course, is unlocking new opportunities, also because the results are very good. So now, how can we interact with these models? How can we take a large language model pre-trained in a general purpose model and ask it to perform our task? We can do this by using the prompt, that is essentially natural language text that we can write, and it is the main tool that we have for describing the task, our intentions, our goal, and so on. So, of course, this is the main tool that we have, and it has to be written in a proper way so that the model can understand what we want to achieve. This operation, the refinement of the prompt, tweaking of some words of the expression that we use, is known as prompt engineering. And among the best practices of prompt engineering that we will see later, there are the definition of clear and specific instruction by avoiding ambiguities, for instance, in the terms that we use, but also the fact that we should provide all the relevant, any relevant details that we know about the dataset, for instance, or about our task, the domain, and so on. Then there is the recommendation related to the usage of delimiters in order to indicate distinct part of the input. We will see later that we can use triple backticks, free hash symbols, but also other type of delimiters in order to clearly define different part of the prompt. And also the few-shot learning technique can be listed as one of the best practice. And it consists in adding some examples to the prompt so that we can improve in some way the prompt by showing to the model some examples. And these examples are in the format input-output, so that we show to the model what we expect to be the output for a selected input. And this is recommended especially in case of complex tasks. So now we can see how to build, how to create, how to write a prompt for our task, named entity recognition and relation extraction, starting with a simple prompt and then improving it in order to achieve better results and improve the accuracy of them. So this is an example of a basic prompt that we can use where we are just defining the task. So we are saying to the model that given a prompt that is delimited by triple backticks, as I said before, are these symbols. We want the model to perform two different steps. The first one is related to the task, the identification of entities and the relations, and then we have the second step that is related to the format of the output. In this case, we are asking to have output in a list format for illustration purposes, but it can be done in different ways that we will see later. In this case, we just wanted to have, for each relationship, a list where we have the first entity that is essentially the source of the relation. In the case of the previous example would be Smith. Then we have the type of the first entity, person, the relation that starts from the first entity to the second and ends in the second one. And in that example would be receives amount, and then the second entity and the type, money. Now we can just insert the text that we want to process. In this case, we are using a text as an example, and the model will output the results. As we can observe, we got some good results, but we want some coarse-grained results because as we can notice here, for the relationship, but also for the entities, we have some finely detailed names. For instance, in the first case, for the relationship, we have that Singh was a central and willing player of Transnet at Transnet. But also Star Engineers is classified as an engineering firm. And this could cause some issue when we consider that our final goal is to create a knowledge graph, so to create something that can be understood, but also used in an easy way. So we want something that we want to create more generic in some way entities and the relations. And this is what the data scientist has to do with these models, use them in an efficient but also effective way, and write the prompt in a good way. This is an example of how the previous prompt can be improved, and we have just added to the definition of the task some details, as I said before, about the most important entity types and the most important relations. So we are just listing what we think are the most important entity types or the entity types in which we are interested. And for some of them, we are adding an explanation or some examples. The same is for the relationship. We are adding for some of them, we are adding an explanation about the entities that this relationship should connect. Now, if we process the same text that we considered before, we have better results. We can also notice that we have works for, that is one of the relationship we inserted in the prompt as one of the desired relationship, and it's the same for organization. Now, at this point, what can happen is that the model can struggle a bit in identifying some entities or relations, in the sense that these entities, these items are present in the text, but the model can have some issue in identifying these items. In such cases, what can help, is the usage of the few-shot learning technique. This is a prompt as an example of the prompt, and here we just added to the task definition and the knowledge graph details an example. This example is in the format input, that is the prompt, and then output, the output that we expect the model to return. And this can improve a lot the accuracy of the model, especially in the cases in which the example is created, is balanced and relevant, considering the complexity, also the grammar complexity that the model will find later while it will process the data set. Now, let's say that we want to return the results in a different way, and we can do this by writing a different prompt. In the task definition, we can just ask the model to return the results in a different way. And this is an example of the example that we can insert in the prompt in case we want to return results in a JSON format. We generally, it's better to prefer this kind of formats because the JSON can be parsed in an easier way, considering the list of strings that we saw before. And this kind of format also allows a richer and more compact representation of the information, because we can add some attributes for entities, but also for relations. Now, despite all this work related to prompt engineering and despite the best way in which you can write the prompt, there are still a few things that you should consider and pay attention to. In our case, we noticed that we asked to the model to obtain less than 10 different entity types, and we obtained more than 200 distinct entity types. Some of them are something we didn't ask to the model to have, such in the case of the example here, we have, for instance, travel and accommodation or accounts, and we didn't ask to the model to have this kind of information, while in other cases, the model might return some very detailed types, such as staff, members, family, people, that can be all traced back to the more generic person. Even worse is the situation for the relationship types, because we got 3,000 different relationship types with a lot of variations and different tenses. Now, we should admit that the models are improving day by day, and the new models have a better ability to follow the prompt instruction, but we can also write the prompt in a different way by forcing the model to return only the results we are interested in, or asking the model to perform a kind of cleansing of the results. But this kind of operation, the cleansing of operation, are something that you should consider anyway. And in our case, we have applied this cleansing operation by using some intermediate nodes and intermediate relations in order to store the results from GPT and then apply on these nodes the operation that we needed for cleaning up the results. We applied two different kinds of cleansing. The first one is just a filtering on the entity and the relationship types by removing the results we were not interested in, both in the cases of entities, but also in the cases of relations, if we were not interested in that types. And the other step is the entity resolution. Entity resolution is the identification and the reconciliation of different mentions of the same entity. And this is something that is not strictly related to the usage of GPT or large language models, but instead to the variety that the language offers, because the same way can be referred to by using two slightly different names. For instance, we have Gupta and the Guptas, so it is mostly related to the fact that we are working with the language. About entity resolution, we have used, apart the similarity of the names of the strings, we have used two strategies, and the first one is based on information retrieved by large language models. Indeed, we can observe in the example that we have some relationship between Sally Messa and the Rainmaker of type alias of, and the same is for Sally Messa and businessman. So by analyzing these results, we can understand that Rainmaker, Sally Messa, and businessman refer to the same entity, so they can be resolved by using a single entity of name Essa with some aliases that could be Rainmaker and so on. While the other strategy leverages the graph structure, and in this case, we can notice that we have a node that is a person with the name Essa, that is the director of VR Laser, that in this case is an organization. And VR Laser is an alias of VR Laser Services Limited that is again owned by Sally Messa. So in this case, we can conclude, we can say that with high probability, both Essa and Salim Essa are the same person, so we can resolve them by using a single node. In this sense, we have used the structure of the graph and the information that are connected to both person and organization in order to solve these entities, these names. About the way in which we have performed this entire process, starting from a structured data to a knowledge graph, we have used our mission-critical graph analytics solution, that is a Hume, and particularly we have used the orchestrator that we have in Hume, and is Hume Orchestra. Orchestra is designed for making data integration easier, and this is what we are doing here, because if we set up a folder, a storage, and we wanted to process this entire set of documents, we can just set up a process that is a workflow in Orchestra that will be applied on each document that is in that folder or on each selected document. And once the information is extracted, it will be inserted, it will be added to the knowledge graph that will be the result of this process. And essentially in the workflow of Orchestra, for each document, we are invoking the large language model. In our case, we are making an API request because we used OpenAI GPT, and then parsing the results and represent these results in a format of nodes and relations. Now, let's move on with the demo that is related to the state capture that happened a few years ago in South Africa, and it followed a leakage of email known as Gupta Leaks. The state capture is a case of systemic political corruption in which private interests or interest of a family, such in this case, significantly influence the state's decisions to their own advantage. And in the South Africa case, this corruption was carried out by the Gupta brothers, helped by some state agencies and important state organizations, and the former president of South Africa. We have used this data because these are publicly available, but in the same way we can decide to process any kind of data in order to produce them and represent them by using a knowledge graph. For instance, real-time police reports, or as I said before, financial transaction records, and so on. Okay, this is the knowledge graph related to the state capture. This is what we have, the final knowledge graph that we have built. So on the left side of the schema, we have the sources of the data that we used. We have some web pages, web articles talking about the state capture, and also judicial reports, the public judicial reports that followed related to the investigation. And they are all broken down into pages for the sake of simplicity, and also because we needed to apply the OCR step, OCR process, in order to represent this kind of pages, this kind of documents in a machine readable format. While on the right part of the schema, we have all the entities and all the final entities and the relations that we have automatically extracted by using the GPT. We have 6,000 pages, but I would like to mention that we have not processed all the public judicial reports about this case. We only have processed 800 pages of judicial reports and 100 of pages related to web articles. And with this small amount of data, we got this huge and informative, very informative knowledge graph. So let's say that an analyst wants to find the most important actors, the central organization in the state capture or in the state capture investigation. We can do this by using one of the Hume feature that is represented by action. These actions are predefined cipher query, and in this case, we are using an action that will return the organization network. This is this network, and we can observe that on the canvas, we have the most important organization that we have in the network together with the links that exist between them. Also, the style of these nodes is based on the results of the betweenness centrality, in the sense that the bigger the node, the more important is according to the betweenness centrality, that is an algorithm that measures the importance of the nodes based on the role that they play in the network, if they allow the communication of different parts of the network of different entities, and in this case, of different organizations. So by observing this network and considering the style, we can understand that the main actors of the state capture are Gupta, we might expect this thing, but also ESCOM, Bosasa, and other organizations, other smaller organizations. For instance, we have Denel, Trillian, McKinsey, Trustnet, and others. Now, let's suppose that an analyst wanted to find the key accomplices of this organization. This is a very important analysis because in some cases, in a real-time scenario, this can help, this identification of the key accomplices can help in the identification of the entire network and can lead to the disruption of the network, so that the chances of the crime being committed again will be, in the near future, will be reduced. In order to find the key accomplices, we can use another feature that we have in Hume that is represented by the grouping strategy. And in this case, we can enable the organization partnership strategy. This is showing to us the communities of organizations that are closely connected, in the sense that we have computed these communities by using the links existing between them of type owned by, so that in the same cluster we have organizations that own each other, that are strictly connected by an owned by relationship. We have two main actors. One of them has Bosasa in the middle. And there are other smaller organizations. For instance, there is Sondol IT that is connected to Bosasa by an organization owned by. But we also have Querano Financial Services or other organizations that are linked to organizations that are also owned by the Bosasa family. So considering the size of this of the Bosasa node, we can say that one of the main actors of the state capture was played by this organization. While on the other side, we have the cluster that has a Gupta in the middle. So if we want to analyze this cluster, we can observe that we have some organizations such as Oakbay Investments or also Optimum Call, but Sarah Computers is another one, that are all owned by the Gupta organization. Indeed, these are organizations that at the time were owned by the Gupta family. While there are other organizations. For instance, we have the biggest ones are ESCOM and Denel. And the fact that these organizations are in this cluster is suspicious because ESCOM is the public electricity provider, while Denel is the military conglomerate. So these are, of course, organizations owned by the state, not by the Gupta family. But if we notice, there exists a link between Denel and Gupta of type owned by, and the same is for ESCOM and Gupta. There is this link that connects these organizations. So what we can do at this time is leverage the way in which we have created the knowledge graph, because it is fully explainable, in the sense that for each node, for each entity, or for each relationship, we can check the page of the web pages or the judicial reports in which the entity or the relationship was identified. And if we use a local action that will run on this on the selected relation, we can explain the reason why there exists this relationship between ESCOM and Guptas of type owned by. Okay, let me search for ESCOM so that we can understand the reason of this link. And the reason is essentially in this sentence. It seems from the text that Guptas controlled in some way ESCOM because they were able to install some person, for instance, Brian Mollefeld, that was the CEO of ESCOM, Hanoi Singh, the financial director, they were able to install this person in key position at ESCOM in order to let them act in favor of the Gupta family instead of in favor of ESCOM. So this explains the reason why this ESCOM organization is in this cluster, because indeed it was controlled by the Gupta family. And this is the other for other different organizations that we have here. They are all owned by the Gupta family or captured and controlled in some way by the Gupta family. Now, let me clean the canvas because I would like to start another investigation. And this is related to money, to the flow of money, because you know that in such corruption cases, people usually steal money and try to hide the source and the target of this money by putting in the middle a lot of intermediaries, by creating a long chain of payments. And classical systems can struggle a bit in identifying this kind of chain, especially when it is very long. While I would like to show you how we can identify these financial transactions, this chain of a very long financial transaction with the graph and especially with the Hume. And also for this reason, we have another action that will return the payments network. Okay, let me disable the grouping strategy. And this is essentially the network of nodes that are or organization, or the other possibilities that these nodes are of type person. And the links, the relationship that we can visualize in this network are a relationship of type organization or person paid to another organization or person. Also associated to them, we have the amount of money expressed in rents that are associated, that are involved in this payment. So at this point, what we can do is to analyze the role played by each entity in this network. And we can do this by using the styles. Again, in this case, we have a different style that is based on the payers network. Styles are essentially predefined visualization that allows us to identify some patterns, to highlight some behaviors. And in this case, this style will highlight the payer's role played by each entity. Let me rearrange the nodes. And as we can observe, the biggest node is represented by ESCOM that paid 56 billion of rents, while Gupta, that is purple for visibility purpose, paid only 5 billion of rents. But if we change the style, if we just highlight a different pattern in the data that in this case is represented by the amount of money received, we can see how the situation changes. Indeed, ESCOM had received less money than before, 37 billion, while Gupta's almost 60 billion of rents, that is 10 times more than the amount of money paid. And this is something that we expected knowing the criminality of this family, but as we can notice, there is a situation of both Gupta and ESCOM that is suspicious, because the income expenditure situation of both these organizations is unbalanced. But while ESCOM is losing some money, Gupta gained money. And as we said before, ESCOM was one of the state-owned organizations captured by Gupta. Also, if we observe all the links that start from ESCOM and goes to other organizations, all of them are of type organization paid to the other, meaning that ESCOM had made some payments. We can observe, we can read the name of these entities, and all of them are essentially entities that we mentioned before, because in the Gupta, because owned by the Gupta. And if I enable again the grouping strategy, we can see that all of them, Optimum, Call, Tegeta, are in the cluster of the Gupta family. And also this entity, Moses Coco, if we expand the relationship works for, we can observe that this person to which ESCOM had made some payments works for the Gupta family. And this explains the reason why the Guptas, one of the reasons why the Guptas were able to capture the state and having these criminal activities for so long, steal money for so long without raising suspicions. Also because they directed huge flow of money, not only to their accounts, bank accounts, but to other organizations that they in some way controlled. And this concludes this demo related to the way in which we can use large language models together with the knowledge graph in order to analyze the criminal networks, identify the main actors in corruption cases, but also the key accomplices, and track the financial flow of money and financial transactions. Thank you.
Thanks to you, Federica. Okay, now we will start with the Q&A session. We actually had a lot of questions answered during this session while we were speaking with the help of Alessandro. Thank you very much, our chief scientist. And we left some of the questions for you. So let me start with the first one. So what are the key learnings from your prompt engineering experiments? And is that transferable to different LLMs than you used in your work?
A very interesting question. I would say that the key learnings of our experiments of the text test that we did are related to the fact of trying to insert as many information as possible and clarify, but also use some names that are that can be easily understood by the model, so that the model can work having all the kind of information that a human would use also if it would annotate this kind of data or work with this kind of documents. And yeah, I think that these key learning points are transferable to different large language models because are very generic, in the sense that you know that the best practices of the prompt may evolve very quickly because new models are appearing every day and becoming better and better. So of course, these models can change very quickly, but the fact that you should explain to the model in the best way you can, it's something that you can apply to different large language models.
Thank you. I will reconnect with one answered question already. I think is important to say it also. We have a question from, again, anonymous attendee is asking us, what is the tool on the screen that you've been using? Is it public?
It is a Hume. It's our graph analytics solution. And it's not public, but if you want to know more, you can contact our sales team. They will be more than happy to answer all your questions.
All right, let's proceed with unanswered questions. Can we use our own models?
We have not deployed our own model, since you know that there are a lot of publicly available large language models, and they also take a significant amount of time to be built on from scratch. So there are a lot of, I think that there are a lot of different large language models, so that you can easily consider one of them that is good enough for the task that you want to perform, and then apply a fine-tuning, because the fine-tuning is also another option that allows your model to work well, considering your domain, and allows you to fine-tune your model for your specific use case in a good way, in a very efficient way.
Okay. Also, thank you very much. Also, there has been an interesting question that maybe you would like to address that is already answered. And it was about one particular problem. And I would like to know if you encountered as well a similar problem during your work. So, okay, we tried GPT, but the results were not good as our data/prompts were somehow censored by GPT. How do you solve this? Have you encountered a similar problem during your work?
We had the similar issue in the sense that we tried to use the Azure deployment, and I know that Azure is applying a kind of censor about on the results, especially if you are working with data talking about law enforcement and related to law enforcement domain. So I would suggest to try the API that is available from the OpenAI organization, so that you can directly test these models. Also because the quality of the results may depend slightly on the kind of the model that you are using. And for some deployments, it's possible that the architecture of the model is the same, but they are trained in a different way and also fine-tuned on a special domain.
Thank you. Okay, let's proceed with unanswered questions again. I will start with this one. Which large language model does your tool use? Hugging Face, DaVinci, Stanford, any other?
Yeah. Our tool currently is in our demonstration. We used OpenAI, but it's possible to use any kind of large language models that exist so far, both in the case of an on-premise model, or if you can access the model by using an API so that you can reach the model using Orchestra and the components that we have in Orchestra.
Thank you. Now the question from Paul. Paul is asking, will there be a GitHub available with the sample code for this project?
It could be. Actually, we have, I would say, a good blog post about this experiment and the prompt that we used, the entire prompt that we used on our website. So if you want to see the prompt and this kind of experiments, I would suggest to check out our blog post. But yeah, it's possible that we will add something.
Okay, we will see. Now there is a question, it's looking at it, it's more for our sales team. Let me see if I can pick someone to answer this one. Are there any trial options? Is it cloud or software as a service? So let me turn on the microphone. This is a question for Christoph. Hi, Christoph.
Can you hear me?
Please go ahead.
Yeah, thank you. So trial is definitely available. So there are two options. Either it's on an environment hosted by Graphaware. So in this case, normally it's some sanitized or synthetic data that a client shares with us, and they can run the testing on a Hume hosted by us, or we can do an on-premise trial as well. And in general, Hume is available. Well, technically, it's available as well as a service or on cloud. However, given the nature of the projects in this domain and the nature of the data, we normally go for an on-premise deployment.
Oh, thank you very much, Christoph, for this intervention. Okay, let's proceed. Okay, here we have an answer to another interesting question. Maybe Federica, you would like to address this one as well. There was a question about how many nodes can you visualize on within our tool on in the knowledge graph, and the answer was that we recommend 20,000 nodes, but it's another limit. Maybe if you like, you can maybe explain why we recommend this kind of limit.
We recommend it because otherwise, it's also difficult to use to navigate the knowledge graph and visualize it. But it's possible to increase this limit because we are implementing actually, or we have implemented recently a good option for loading this data in a short way or shorter way, considering the past test.
Perfect. We have two more questions. What would you recommend for on-prem usage? I'm not sure if I understand the question. Is it clear to you, Federica?
Yeah, I think that it's talking about the large language model. So I would suggest Llama 2 or also Mixtral that are good models, but there might be other different models that have appeared in the last days or are appearing in the near future.
Thank you. And we have the last question. Maybe some other will come while we are answering. So from William is asking, if one doesn't have the ability to purchase the services offered by OpenAI to use their model, what open source options are available? So an advice.
OpenLlama is one of the model that is open source. But yeah, otherwise Mixtral, I think that it's another option, as I said before.
Okay.
And that's
perfect. Done. So we answered all the questions. I want to thank you, Federica, for the presentation, the demonstration, and your answers. Also, thank you, Christoph, and other colleagues that have been contributing. And as I said before, we'll be sending the recording shortly after this session. I wish you a nice day.
Thank you.